Hello, and welcome back to my math YouTube series. For those of you who don't know me, I'm Andrew, a local Bay Area tutor. I offer in-person and virtual tutoring, and I'm the one behind these helpful videos. Be sure to check out my website via the link in the video description below, and please give this video a thumbs up if you find it helpful. Now, on to today's subject, the unit circle, specifically the trig unit circle. The trig unit circle was something that honestly scared me when I was in my trig class. But hopefully by drawing it out for you and explaining some of the common angles and radian values that exist around a circle, it won't be as scary for you. So I'm going to start by drawing a circle here. And I'm going to put a y and an x axis on this circle. And first I'm going to label some common degrees here. So as we go around a circle, we go 0, 90, 180, 270, 360 if we cut it up into 4 pieces. Now radians, there's 2 pi radians in a circle, so we can go around by units of pi over 2. So I did that. And I'm also going to add coordinate points in green here. So the middle is our origin, 0, 0. And then we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1, respectively. Next, I'm going to split each of these into what will now be 45-degree angles. So we'll have 45 degrees, and then 135 degrees, and then 225 degrees. Next we have 315 degrees. So at these areas, this is, for radians, that's 1/2 of pi over 2. So that would be pi over 4. So you can almost count those gray lines, the 45-degree markers, in terms of pi over 4. So we go pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Next, to get the coordinate points, we have to think about what triangle this makes. It's a special type of triangle, which I do have another video on. This is a 45, 45, 90-degree triangle. If you don't recognize this math or understand how it works, check out my math on the 45, 45, 90-degree triangle in the special triangles video. You'll totally understand it then. So we get our coordinate points for each of these systems. And when we get the coordinate points for one, it's easy to get the coordinate points for all the others. We just need to change the signs according to what quadrant of the graph they're on. So the next thing I'm going to do is make this even a little bit more detailed and add in some other common angles. Now we're going to be going by every 30 degrees starting from 0 degrees. So we'll go 0 degrees, 30 degrees, 60 degrees, 90, 120, 150, 180, 210, 240, 270, 300, and 330 degrees. And so to figure out what these are in radians, we can now jump in terms of like pi over 6. Because if we go 0, 30, 60, 90, 120, 150, 180, that's 1, 2, 3, 4, 5, 6 jumps to pi radians, which is halfway around the circle. So that's why I counted these in terms of pi over 6. And to go around twice, that would be 12 pi over 6. Next, let's figure out some coordinate points here. And this is another type of special triangle we have. I'm going to figure out the 30-degree coordinate point first. This is a 30, 60, 90-degree triangle. So notice how I got that point. And then the other triangle, I'm going to try and like rotate this to kind of show you how it should look. But see how that can be overlaid as long as I rotate the triangle vertically? So this is also a 30, 60, 90 triangle, which again is another type of special triangle. If you don't remember that, check out my special triangles YouTube video. And then to get all these points, it's just a matter of thinking about what sides line up and what quadrant they're in respect to the sign of each part of the coordinate point. And this is it. This is the big bad unit circle. Basically with almost every 15 degrees around the unit circle being equal to pi over 12 radians. So I'm going to end with this on the screen. Thank you so much for watching, and I'll see you next time.